Hello everybody, we are going to see about the Indian power sector. After India got independence, our Indian government has made many 5-year plans to develop the Indian nation. They concentrated on the industrial sector, agriculture, education, electricity, and even the railway side and military side and so on. From 1990 onwards, India has become a emerging power among the world in the economy status. Indian economy is the 10th largest in the entire world by nominal GDP in 2011. If you see from the 2000 onwards, our Indian economy has become very good, and the diagram here is represented from the 2005 to 2013, and if you see the Indian GDP growth, that is gross domestic product growth level, actually the GDP they will calculate for each and every country for their economic status to understand about the economic development in a particular nation. If the GDP growth of any one nation is so good, then we can say the financial status or the market value of the product is good. If there is any inflation on that one, then we can say about the nation's weakness. It is keep on getting down in the market level among the world. So in this way, if you see from 2005 to 2008, our Indian economy is so good, and then there is a slight inflation in the GDP growth. Further, they somehow manage, and they brought up bring the GDP from 6.7 to 9.3. However, during this 2008 and 9, there is a little bit problem in the economy status. Even though they developed, again they have some problem, and they started the economy growth, again it comes down. Even though India develops in many sectors like industry, even education and the research side, the major problem of this GDP inflation is, we can say, in the power side. Because if the electricity is good in any nation, then the GDP growth of that, or economic of the nation should be so good. India has the fifth largest electricity generation capacity and sixth largest energy consumer, around 3.4% of global energy consumption. As we seen, power crisis is a major issue for slow downing the economic rate, Indian economy rate. Power crisis here, it means a shortage in power. In India, at many places, last 5 years, there are many power cuts are there, that means shortage of power. It means the power generation itself, it is not sufficient for the consumers who are demanding the power. Basically, the industrial peoples, because they are all the deciding about the developments of our Indian nation or economy. They are the main part in that economy system. So if you want to, in future, if we want to increase our economic growth, as well as if you want to make a stable position in the economic GDP growth, then we have to make our electricity system as good condition. Whatever the demand raised at the consumer end by the industry people or agriculture side or railway side, always we have to satisfy. The electricity side, we have to increase the generation, and always we have to satisfy the demanded power at the consumer level. In order to look on that one, the future demand, how much this will increase because of the industrial developments. We have to predict the power demand for the future so that we can go for expansioning the power system and we can supply the power in the future as good as possible. In 2007, McKinsey and Company, they made one survey powering India the road to 2017. For 2017, how much will be our power demand? They have taken some survey. If the India grows at an average rate of 8% for the next 10 years, then our power demand will be 315 to 335 gigawatt in the year of 2017. That means they made the survey during 2007. At the time, the installed capacity was only 114 gigawatt. So India needs generation capacity of at least 415 to 440 gigawatt so that it can meet the power demand of 315 to 335 gigawatt. So what are all the key factors they have taken for the survey means rise of industrial power demand, commercial demand rising at 14% over the next 10 years, power for all by 2012. This is the one more important thing which it was made by our Indian government. And the fourth one is realization of demand suppressed due to the load shedding. And one more survey was made. The total demand of electricity in India is expected to cross 950 gigawatt by 2030. That means at the time of 2030, at the year of 2030, our demand will be 950 gigawatt. So you just think about how much power we have to expand it. And even one more thing is also we have to keep in mind the coal-based thermal power stations as well as nuclear-based power stations are all having many problems and many issues are there in the atmospheric level, as well as we have to now concentrate more on non-conventional side like wind energy, solar energy in this side. So we have to think about how much amount of power we have to install for the future development. If we are not concentrated much on this future prediction, load forecasting type, then we have to face a much economical problem in the future. And also, as I said in this, one of the key factor, power for all by 2012, our Indian government has made during 2008. Each and every part of the India has to be completely electrified. That means there are many villages and many hill stations, they are not having a power supply. So the main thing, we have to install the transmission system as well as distribution system to reach the power at each and every part of the country, so that power it will reach to all. This further increases the demand, and that also we have to take into account for expansioning the power system, complete Indian power system. Evolution of Indian power sector. Evolution of Indian power sector we can classify into two forms, that is before 1990s and after 1990s. Before 1990s we can call as a pre-reform, and after we can call that as a post-reform. Earlier days, India has first initially started his first power generation in 1897 in Darjeeling, and also 1902 Sivasamudram in Karnataka, they started one more power generation. These are all the first power generation that was happened in India. During our independence, 1947, India's installed capacity was 1.3 gigawatt of power. While we are comparing from that one to now, it is about 200 or 230 gigawatt right now. Indian Electricity Act was first introduced and established by the Central Electricity Authority on 1948. Though Electricity Act was earlier days during 1910 also it was there, but after independence government has framed the Central Electricity Authority to govern the complete network of power system, both central level as well as state level. Also, the central government set up some power stations, central based power stations, coal based thermal power plants, nuclear based thermal power plants, hydroelectric power plants, and these power plants are governed by individual corporations like National Thermal Power Corporation and National Nuclear Power Corporation and National Hydroelectric Power Corporation. These are all set up during 1975 and 1987. Post-reform, that is after 1990s. You might be remember while we are starting our lecture that we have started that the economic growth of India has emerged during the time of 1990s onwards. We have mentioned about the economic growth. Especially if you see here our Indian electricity also we have divided between before and after 1990s. So after 1990s there are many amendments, many rules they have framed, and both in electricity sector as well as economy. That means there is a relation. If you see that in electrical sector also they have developed, made many changes on that one, so that also we can say our Indian government also has emerged as become a very big developed as a very big country. If you see after 1990 in the Indian electrical power sector, National Power Transmission Corporation was set up during 1989, and that was again renamed as Power Grid Corporation of India Limited, that is PGCIL, in 1992. Also, already we have seen during 1975 and 89 some of the national corporations or corporations, that is NTPCL, NHEPCL, and Nuclear Power Corporation, THDL, that is Tehra Hydro Development Project. So these are all under the separate individual corporations, and they are all became under the Power Grid Corporation of India Limited during 1992 and 93. From 1994 and further onwards, the complete whole nation is divided into 5 regions, and according to the region they started a load dispatch center. The load dispatch centers are nothing but it comprises of many states as per the regional condition, and their all generation as well as loads are connected on a particular grid. So we framed as a 5 load dispatch centers in order to maintain a good and supply a quality of supply to the consumers. In 1998, Power Grid was notified as Central Transmission Utility by the Government of India. In 2009, Power Grid established National Load Dispatch Center at New Delhi. Under the Power Grid Corporation of India, these 5 load dispatch centers they have established at the 5 regionals, even though in order to maintain those individual load dispatch center, they are all governed by the common load dispatch center, that is called National Load Dispatch Center, which was located at the New Delhi. As you all know that a power system network means it starts from the generation side to the utility side. So it comprises of many power plants, integration of or synchronization of many power plants along with the transmission system and distribution system, and finally it reaches the utilization part. As you see here, it starts from generation side to generation first, and then transmission system, and then distribution system, and at last utilization side, that means consumers. This is somewhat, if you look the diagrams, it's like a one-way path. It starts from generation to utilization. Whatever the power generated at the generating station, it has to be transmitted through the transmission and distribution, and we have to distribute the power to the consumers. But in nature, it will not be like that. So here we have planned like a grid. We framed the grid, and all the generating station as well as loads are all interconnected completely. So the place where or which we are calling that as, which we are all connected, all the generating station as well as the loads, we can call that as a grid either, or otherwise we can call that as a load dispatch center. If you call in a state wise, if you say we can call that as a power grid or state power grids or state load dispatch centers, if it come across the regional side, then we can call those as central regional load dispatch centers, or otherwise we can call that as regional power grids. First of all, we should know about why India separated in regional wise the regional load dispatch centers. Especially if you see in India, the industries as well as the load centers, that means the population of load centers that are all not scattered evenly in all over the India. If you take at southern region, the Karnataka at Bangalore, Tamil Nadu in nearby Chennai. So these are all the places where most of the loads are concentrating on these places, and remaining places, if you see, there are very less amount of loads, industrial loads. I am talking about the industrial load or the major loads. And in the same manner, if you see in the western region, there are many industrials are there, nearby Mumbai and Gujarat, and even in Madhya Pradesh, there are many industries are there. And if you see at the northern region, north side, Jammu and Kashmir, the load is very much less. While you are comparing between with the downside of the northern region downside, there is a Delhi, and in and around the Delhi side there is a very huge load is there. So there is a difference between each and every region. There are load difference itself. It is there. Not only that one. Power generation. You take the power generation. Power generation you can't put wherever the load is available. We are all from the earlier days. We have started to install thermal power station, nuclear power station, and then hydels. So where the sources are available, the nearby the sources only we can install the generating station. Here if you see in the eastern region, coal is very much high. We are getting the coal from the eastern region, and also we are transporting the coal to each and every thermal stations from this region only. And if you see at the northeastern region, the availability of hydel energy is very much high, but we are not able to utilize that properly there, because if you install the hydel power plant there, the load is very much less in that portion, and even we can't able to put the install the power stations there in order to transmit the power from that region to the next region. There is a problem in evacuating the power from northeastern region. And also if you see As I said, the western region, it has many industries, so that we have to put a very big power stations there in the western region. Also, if you come down to the southern region, the main load dispatch centers are at Chennai, Hyderabad, Bangalore, like this. So if you see the load population in these areas, if you want to distribute the power evenly, then you have to generate the power wherever it is nearby the availability is there, and if it is not there, then you have to export the sources from other places, and that transportation also it should be feasible. So that's why the load dispatch center, regional wise load dispatch centers are made, and later on they are all interconnected properly through the interlinks. That means through the transmission lines, very large transmission lines, and through those transmission lines we are importing the powers, and even we are exporting the powers from region to region. Figure shows the block diagram representation of a power grid or a load dispatch center. As I mentioned earlier also, the load dispatch center or power grid is nothing but a common place which we can connect a many number of generating stations as well as the load areas. Here we will get all the information about the generation as well as the load parameters. For example, what is the power generation, what is the real power, reactive power, what will be the voltage at each and every node, either it may be at the generating side or it may be at the load side, and the parameters like whether the circuit breakers are in on condition or not, transformer condition, relay settings, all we can get information in a common place so that we can manage the whole electricity network. So this is the place where we can make all, we can get all the information in that place, and easily we can manage the complete system. Load dispatch center. As I mentioned earlier, there are 5 load dispatch centers are available in our India. So those are northern region, northeastern region, eastern region, southern region and western region. Those load dispatch centers are available at northern region is at New Delhi, northeastern region load dispatch center is at Shillong, eastern region load dispatch center is at Kolkata, southern regional load dispatch center is at Bangalore, and finally the western region load dispatch center is at Mumbai. Though there are 5 load dispatch centers are there, we have to commonly organize all the 5 load dispatch centers. For example, from one region to another region, if there is any need of exchange of power is required, then we should not go for individually, we should not command. There should be a common person all over that. Through that only, media only we have to go. So for that only there is one more load dispatch center called National Load Dispatch Center, which cover all these 5 load dispatch centers. So this National Load Dispatch Center is again is located at the New Delhi. As I said, these 5 national load dispatch centers, they are all individually operating from 1990 onwards. Even though earlier also in state-wise they are all linked, interlinked. Though after we have the regional-wise we separated, we can say during the time of 1990s, we can say there are around 5 frequencies, or we are operating the grids at 5 frequencies in India. Though here I am not meaning we are operating our Indian frequency or at a different. Our Indian frequency is 50 Hz only, even though in the grid wise we have separated here. Okay, so in that manner, if the regional wise we can say the northern region, complete northern region, they are operating at 1 frequency. That means they are all completely integrated and they are operating separately. And in the same manner, northeastern region, eastern region, their frequency are all operating at there are different frequencies of there. But though five regions are distributed in the five frequencies, during the time of October 1991, East and Northeastern regional load dispatch centers are synchronized so that we can easily exchange the power between the Eastern region and Northeastern region. During March 2003, the Western region is synchronized with the East and the Northeast region, so that at that time we are operating the complete India with three frequencies. August 2006, the northern region synchronized with the central grid. The central grid is nothing but the east, west and northeast already, which are synchronized, that one. So now north is also synchronized with the central grid. So now we are having two different frequencies in India. Last December, that is 31st December 2013, the southern region is synchronized with the existing region grid, that is central regional grid. So now India became one grid, one nation and one frequency. Because of this, we can export the power from one region to other region, and even we can import the power from one regional to another region with proper agreements. Apart from regional load dispatch center connections, we are also having links with neighboring countries like Nepal, Bhutan, Bangladesh, and right now we are planning also with Sri Lanka. There are many transmission systems that are linking between the neighbor countries. Either we can import or we can export the power. As you see here, the Nepal, there are over 16 links of 132 or bar 33 or 11 kV systems are there. We can import or export the power through this one. Bhutan also we are exporting the power through the transmission systems. And also there are many transmission systems we are even planning for future, and either with Bangladesh or through Sri Lanka we are proposing many new projects to export or import the power. Basically, if suppose in some country the source is very high and the nearby areas, the border areas of India, if there is any scarcity of supply, then we can import the power from there. Suppose if we are having huge power source here in our nation, we can even export the power from here to there if they need, with proper agreement, financial agreement. Right now also we are having a plan and plan to the Sri Lanka to import the power through the underground cables. Control areas and hierarchical structure. As we have discussed about the complete electricity in our India, we have started our higher commanding level from the National Load Dispatch Center. And what is the least point? So if you see here, as I mentioned, the National Load Dispatch Center is at the top level, apart from this Power Grid Corporation of India, CEA, Central Electricity Authority. Apart from them, the National Load Dispatch Centers, from there we have to start the hierarchical. So it is the higher order in giving some command and issuing some all the things. So National Load Dispatch Center, the next one is a Regional Load Dispatch Center. After that it will come the State Load Dispatch Center for power grids, and then Sub Load Dispatch Centers. The next one is the last one is the Remote Terminal Unit. So this is about the hierarchical, and if there is any commands it has to give, means it has to come from the National Load Dispatch Center to the lower one is the Remote Terminal Unit. And also we are having for 5 load dispatch centers separate websites are there, and we can open those websites and we can find the load schedules for the next, for the yesterdays and previous days. All data will be available, and also we can monitor the current frequency, grid frequency, as well as the complete schedule. If you want the earlier data, the complete history is also available in the website. So from this we can easily monitor or study about the each and every regional load dispatch center. Here it is showing a southern regional load dispatch center. In the same way, if you want to study northern regional load dispatch center, or otherwise a northeastern grid, you want to study about the western grid, for each and every one the separate website is there. You can go through, and if you want any analysis, you can make from that one. Now we will see about the power generation in India. Right now, how much power we are generating, what is the installed capacity, and all we will see, and what is the contribution of thermal power plant, nuclear, like that we will see. The total installed capacity in India during the time of independence was 1.7 gigawatt of electricity, installed capacity of electricity. Right now, we are having 234.6 gigawatt of power. This is the installed capacity, total net amount of installed capacity in our India. So if you see, from independence to this time, we are having a installed capacity of 234.6 gigawatt. Then, as we have seen in the power demand for future, during 2030 our requirement will be 950 gigawatt of power. So during this 60-65 years we have developed our electricity generation from 1.7 gigawatt to 234.6 gigawatt. Then within one more 15 year itself we need the generation of around 1000 gigawatt of power, 1050 gigawatt of power as per the requirement during the time of 2030. So now we will see about the contribution of each and every side. So it depends upon the source. If you see, the thermal power station contribution is 68% among the 234.6 gigawatt of power. Thermal, we have to reduce it because atmospherically it makes pollution. Not only the thermal, even nuclear also, it is very much harmful. So these thermal and nuclear, we have to reduce the percentage, but it's not possible to reduce. We can, by improving further, we should not go for increasing the capacity of that one. Instead of increasing the thermal side and nuclear side, we have to more and more concentrate on the renewable side, renewable energy sources like solar, wind, even hydel also if it is possible. But hydel is a climatic one. During winter season we can generate more power from the hydel system, but during the summer in some particular area the problem of water is there, so it's not possible during the time of summer. If you see the hydel contribution 18%, it's a very much less. And also if you see the renewable energy source including a wind energy, solar energy, the total net contribution to the India is 12%, and nuclear it's only 2%. And if it is safe and good, then we can increase, because with the help of nuclear energy we can extract more electricity from that one. Not only the electrical power, there are many research are going on under the nuclear energy. So if we properly utilize the nuclear power, then we can utilize the complete energy of that one. So here this table it's again shows in terms of megawatt as well as in terms of percent, as we mentioned in the pie chart. Here it's a tableized. The next one is a sector wise. So as we said that national wise the central sector is there as well as state sector is there and private sector is there. The sector it means the generating station, state generating station, central generating station and private generating station. So they are all governing separately. State generating stations are governed by state governments and central or central government, and private also the central government issued the notice to operate to allow the private generation companies. So if you see among these three, the state sector it contributes 39% in our India. So 39% means all over the state, if you include the contribution of all the states to the electricity board, it's 39%. Central, it comes under 28% and private contribution is 31.88%. Now this is again a bar chart for the regional wise, and if you see here northern region, western region, southern region, eastern region and northeastern region, among these all if you see the contribution of major contribution of power generation is from western region and the next one is from northern region and third is the southern region, and if you see from the northeastern region there are very less amount of power generation is there from that one. Most of the areas are hilly areas and it's very difficult to evacuate the power. We have to build the transmission system over the hill range and then only we have to take it. In their local area there is no any much load available in that particular area. So it's if you want to put there then the wastage of money will be there, and it's not possible financially, it's not feasible to put generating stations there. And one more thing also we have to see, if we are talking about the India also we have to think about the islands. So islands also separately it is there, but it is no way connected with the India. In future it may be there may be a connection interlinked through the underground cables through water. There may be a future plan, it may come. The next one is about the per capita electricity consumption in India. So what is the meaning of per capita electricity consumption? It's about per year one person how much energy he is consuming. This is very important to see about the development of a nation. If a person energy consumption increases, then automatically the nation also we can say that particular nation also it is developing. If you see in US, then US is economic growth is very good and their GDP growth is also good. Also if you look at the per capita energy consumption of the US also that will be a good range. Per capita electricity consumption during the time of 1950s, it was 15.6 gigawatt hour. That means 15.6 units consumed during the time of 1950s. That means per person he consumed 19 units for the whole year. So that means you just think about the whole year the one person need electricity need is only 15 units. Just to compare right now how much we are having right now in 2000 as per the 2012 data, a person he is consuming around 917 units. That means while comparing with 1950 it's a very much huge, and we just think about how we have developed from that time to this time. And this is a chart, it shows various countries per capita energy consumption between the year 2009 to 2010. If you see here among this chart, Canada places the first one. Canada people, they are consuming very large energy for their needs, and the next place it comes USA. Third one is Australia. In the same manner, if you see, India is just having 917 as per 2012, but this figure it shows for 2009 and 10. Here it is mentioned 819 and 884 kilowatt hour. So while comparing with US, Canada and Australia, we have to think definitely how much we have to develop further. Okay, so as I said in the earlier time, a nation development, if you say, it depends upon the GDP growth. Also, if you see, the GDP growth inflation is because of the major issue in the problem, power. The power crisis, if we avoid this power crisis by proper planning of future, then we can satisfy the rising demand in future through the power generation, and we can easily develop the economic growth of India.